Okay, for the first question, we want to know how many joules, how much energy is being expended for a swimmer, an Olympic swimmer, to be able to swim 50 meters in 22 seconds. And so we just take the watts that were given to us, 800 watts, which is joules per second. And we know that it's taking them about 22 seconds to cross 50 meters. Seconds cancel. They're doing it at 25% efficiency, and so you multiply across and you get 4,400 joules used to cross the pool. And then to find out per stroke, we knew that it was taking about 30 strokes to go that distance. We take the amount of joules, divide by 2, because we know that half of the energy is being used in the arms. Get 2,200 joules, divide it by 30 strokes, and it's about 73.3 joules per stroke. For the next question, we wanted to know, we wanted to know how much ethyl alcohol we would need to be able to be flush with the ice cube sitting in the water. So we start off at the beginning. We have the information about the ice, the alcohol. The ice's density is 0.917 grams per centimeter cubed when you converted it to centimeters. And then the volume we can figure out using the length of each side that was given. So we know that the volume is 8 centimeters cubed. And then we find out the mass because we know that density equals mass divided by volume, and so we can rearrange that equation so we can find out that the mass of the ice cube is 7.336 grams. And then we know that the weight of the displaced water equals the buoyant force on the ice cube by the water, so we know that this mass is going to equal the volume of water that's being displaced. And so what we end up doing is using so I've solved for D. So D ends up being the amount that's under the water, the amount of the ice that's under the water. So I didn't know what that was. We used the area of one side and the volume to find that out. So it ended up being 18.34 millimeters under the surface of the water. And then if you just subtract, because we know that the one side of the ice was 20 millimeters, if you subtract that, then you get 1.66 millimeters, which was above the surface of the water. That's the thickness of the layer of the ethyl alcohol that would be needed. And we know that just what was given in the problem, that ethyl alcohol's density is less than water, and so when we pour it on top of the water, it will stay on top, and so you can just pour that amount. For the third problem, we were given information about a metal, and then we needed to find the density of the metal and the specific heat of the metal to be able to find out what the metal was. We were given the volume in inches. We converted it to cubic centimeters. We were given the mass and the initial temperature and the final temperature. Once we convert everything, so I converted it to kilograms for later, but we have the volume and the grams, and so we can find the density, which was 7.14 grams per cubic centimeter. And then for the next part, we use our MCAT equation. We have the mass in kilograms and we wanted to use kilograms for this part because the other specific heats of aluminum and water I gathered in joules per kilogram, so we want everything to be in the same unit. So kilograms times the change in temperature um, temperature final minus temperature initial times the specific heat that we're looking for. And then for this part, on the other side, we take the mass of the aluminum times its specific heat plus the mass of the water times its specific heat. Calculate that and then multiply it by the change in temperature. And then you end up with negative 386.69 joules per kilograms Celsius. And in chemistry, at least, this would indicate that would be like an exothermal reaction. Anyway, that's giving off that amount of heat. And the metal was zinc.